Hello everyone, welcome to the video lecture series on Z transforms. I'm Mayur Gohil. Let us begin with the prerequisites that would be needed for the Z transform topic. And the first formula that I give you here is the following. The following expansion for 1 upon 1 plus Z. Now this expansion is 1 minus z plus z square minus z cube plus z raised to 4 minus and so on. What is very important to note over here is that the expansion has alternating minus plus sign. If we just ignore the first term, there is a plus sign then, so then it is minus plus minus plus all throughout. Okay, and then this term that you see in the summation, I call this as summation form of the expansion. Okay, this is the summation form of the expansion, and or you can just call it as a series also, summation or the series form, that would be also the correct way. And why are we interested in this? Because what interests us over here is this term, the term that you see over here, the coefficient coefficient of z to the power r. Okay, coefficient of z to the power r is of our interest. That is where why we are doing this, or the what do you even call this as the general term, the general term. Okay, so that is what is of interest to us, that is why we go through this. Okay, now when we do this process, there is one important condition that comes into the picture, which is uh, mod of z should be less than 1. Okay, that is the important formula there, and along with the condition. Now let us go for the next formula. The formula says it is, yeah, the second one, it is 1 upon 1 minus z. What do you need to do is, in the expansion formula, you just replace just a minute, I erase this here. You replace z by minus of z in the first formula, you get the second formula. That's it, we don't have to do much more. And you can see now that minus 1 to the power r will vanish because everything is positive. So summation r going from 0 to infinity z to the power r is a series over here, and then you have where mod z is less than 1. Okay, now the next expansion is this, along with the condition that we need to remember is for here, it is 1 upon 1 plus z the whole square, 1 minus 2z plus 3z square minus 4z cube plus 5z raised to 4 minus and so on. And then it is summation going from r equals to 0 to infinity minus 1 to the power r times r plus 1 times z raised to r, where mod z is less than 1. Now this is a little bit a different kind of thing, how it is derived from the first one. It is actually by taking the derivative. I won't bother regarding right now the derivation and all that, but yes, it is just by taking the derivative. Okay, of the I can give you just the hint over here, that you take the derivative. I'll just give you that if you are comfortable, if you want to derive all these things, you just have to take the derivative for take derivative 1 with respect to z on both the sides, you will get the answer for the third one. The third one will be derived from itself. Okay, yeah, that is how it is. And then let's go for the next formula. Again, the very similar version of the same. It is you, what you need to do is replace z by minus z in the formula number 3. Okay, and what you observe each time whenever you do this replacement, that minus 1 to the power r is vanishing. Okay, so in the first one also minus 1 to the power r vanished, and again in the second one it happens the same way. Now one very very important formula comes here, is the fifth one, is log of 1 plus z. Now this formula is nothing but z minus z square over 2 plus z cube over 3 minus z raised to 4 over 4 and so on. And it has a very unique series because the runner we are here taking is that r is beginning from 1 to infinity. It's going from 1 to and going up to infinity. Okay, from 1 to infinity. In rest of the series it was going from 0. Okay, so that's what I have kept it, a little slight difference I have kept, so that we can remember it properly. And the term over here, the rth term or the general term coefficient is minus 1 to the power r plus 1 over r. Again, the condition for each of the 5 expansions that you can see is mod z is less than 1. We do need to remember them all throughout, because it is on this condition where the entire game of the question can be changed, that is very very important. So these 5 formulas are the basics that I would treat, or you can call them as the most important formulas or whatever, but these are the most crucial and the most important one. Let's go further. And then comes the another standard formula. These are very very standard one. So the sixth one that you see is e to the power z expansion, and now here the expansion of the series is 1 plus z square over 2 factorial plus z cube over 3 factorial and so on. And the series formula that you see is z raised to r over r factorial, where r runs from 0 to infinity. What changes here is the condition. The condition is mod z is less than infinity. That is what is the condition that we have. And again, like the derivation of sin z and cos z is from the sixth formula. We won't go into the detail of the derivation, but we will take the derivation, we will take the formula as it is over here that I am giving you, so you can trust it on this and we can go further, because that is where the whole crux. Now we do not have to go for the actual derivation. We would be taking the help of these formulas in order to understand the pattern in the z transforms. Okay, so that is what is required. So just these 8 formulas would form the basic or the basis of the entire Z transform topic, along with the definition and all. So these are the most important formulas for prerequisites. So I would like to conclude my short video lecture on prerequisites at this stage. Till then, keep solving good amount of mathematics. I'll see you soon with the new video lecture. Stay tuned. Thank you.